Welcome to the Tank Magazine podcast. I'm Josie Mitchell. In this episode, I'll be speaking to Heather Dewey-Hagborg, an information artist and biohacker whose new artwork, How Do You See Me, is showing at the Photographer's Gallery. We talk about how biopolitical art practice can shed light on the ethical dilemmas around the algorithmic use of data and imagery. As I was reading through your work, it was making me think about the surely just explosions of academic work that must have been born in the last few years around these ideas of identity and also just knowledge. It's just so interesting. I feel like it's like basically probably hundreds of, like, even though I left university, I guess probably now a decade ago, give or take, like that time since then in terms of knowledge theory must just be insane. It's so fascinating. I guess we're just in this place where
I think in some ways it is and in some ways it isn't. So I think when we look at things like genomics, there was this huge explosion of research, and then in a way that kind of had a peak and then began to splinter into lots of other omics. So looking at like proteinomics and things like that. So this realization that the knowledge of what makes us is so much more complicated than the genome. And that needs to come together with lots and lots of other similar,
like the 3D structure that protein will form or something like that.
Exactly, yeah. And looking at all of the cell and all these different kinds of interactions and epigenetics, so that it's turns out to be way more complicated than just looking at DNA.
One of the things I found really interesting about what you talk about is this idea that in a way algorithmic processes and machine learning can sort of just move around that idea. It's incredibly complicated. It's going to be difficult for scientists ever to maybe in 10, 20, 30 years figure this stuff out. But in a way, machine learning and predictive capabilities almost allow you to move around that problem and just say, well, we don't know why this causes this, but it just does if we have enough data.
So that's exactly this tension that exists in biology these days, is between kind of the geneticists and the genomicists. So between looking at causation and looking at correlation. So there's a kind of group that is still very much interested in understanding the structure of things and really understanding in detail how something is expressed, how it comes to be, how it's encoded, how that works in detail. And then there's this kind of opposite school that's very much related to our kind of big data world that we see online and everything in our lives. And that's also reflected in how our innards are studied in a way. I mean, so how our biology is studied. So the genomics school is much more of this big data variety that is looking at mountains of information and saying, well, actually, maybe we don't need to know why it works. We just know that it works. And so it is this really interesting tension between these two camps that Stranger Visions kind of explores in that way, definitely. And that was a project that began in 2012. And so I worked on this series of portraits from Stranger's DNA, 2012 to 2013. And that project really launched me in this whole direction of getting deeper into biotechnology and learning about biodata, thinking about the aspects of possible biological surveillance, and then ultimately thinking about how our most personal relations change as well, as these new biotechnologies grow and shift and change our consciousness and our sense of identity and our interactions with each other. So how will biotechnology shape our social futures as digital technologies are now?
So you would say that this was the sort of almost first biotechnological art project that you did. It sounds like something on the edge of legality in a way, so you're finding examples of things like chewing gum and cigarette butts on the street and then using that to Well, what are you doing with those things? Yeah.
So I took individual cigarette butts. So I would collect them off the streets of New York and then put them in little baggies. And I brought them to the world's first community biology lab that had just opened up down the street in Brooklyn called GenSpace. And I took a so-called biotech crash course there and learned how to extract DNA and how to amplify it and how to analyze it. And then I worked with the scientists there who mentored me through the process of really doing this kind of forensic work and then trying to analyze the data from that. And then I took the data and connected that up with a computational model of a face. So I had been working artistically with machine learning for quite some time at that point. I'd done previous projects around facial recognition. So I knew that you could kind of have this 3D model of a face that could be morphed, that could be changed along different lines, and that you could have these different kinds of axes along which a face could be manipulated. And I knew that this was research that was happening in the facial recognition field. And so what I did in Stranger Visions was appropriate this model that's used for 3D facial recognition and take this model that's usually used for predicting a face, for matching a face, and turn it into something that instead could generate a face. And so I would take the profile, this probabilistic profile that comes from the DNA sample, and then hook that up with this morphable model of a face, and then predict maybe, let's say, 5-6 different possible versions of what someone might look like based on that DNA profile. And in Stranger Visions, I then would choose one that resonated with me in some way. Maybe it was a face that reminded me of someone, or made me feel something, or had some look that just stood out to me. And then I chose those faces and 3D printed them life-size, full color, and show them along with the sample and the data that was produced. So it was meant to make people stop and think about their DNA, basically, to think, you're shedding this data all the time and you're not giving it a second thought. And here we're having all kinds of conversations about electronic privacy, but you've missed this bodily privacy. You've missed this bodily data that is totally vulnerable and really not much discussed.
How did people respond to the exhibition? How did they take it?
I mean, it caused a big to-do.
Yeah.
So I suddenly found myself, with my phone ringing off the hook and like journalists coming, and I had received lots of love mail, but I received lots of hate mail.
Really?
And people were really passionate about it. And that was very interesting because I'd been making work for some years before then, and trying to, in my way, get at these questions around the politics of machine learning. And obviously was struggling in my practice to figure out how to make that something that people could relate to, actually, because it's kind of these esoteric ideas. And I wasn't at all expecting to have this reaction. I thought, okay, this will be another piece, and I make it and put it out there, and maybe it'd be nice if like 1 or 2 journalists were interested and wanted to talk to me about it. But I didn't expect to end up like 3 times on CNN and suddenly.
What button do you think you pushed?
I think it was so in this moment, like let's say 2013. It was sort of. First of all, there was the 3D printing thing, so 3D printing kind of exploded in that moment. And then 2014, we had Snowden. So there was this kind of explosion of interest in surveillance that happened kind of right around the same time as well. And 23andMe was starting to take off then, so people were increasingly starting to think about personal data, like personal genomics, and what that might mean. So I think it was this intersection of these 3 things that were both fascinations and concerns.
Yeah.
And it just kind of hit that. So it ended up being discussed in press that ranged across those fields, you know, whether it would be cast as this surveillance thing or as this like cool biotech thing or, you know, this cool 3D printing thing.
Yeah. It's interesting because it sounds like for you the thing that was the most disconcerting was this sort of switch from predictive to representational.
Mm-hmm.
Right, so you're sort of, which actually comes sort of maybe is a sort of through line perhaps through some of your work. So rather than predicting faces using DNA, it's actually generating a face that maybe never exists or has never existed.
Definitely.
Yeah.
It doesn't exist. This is a total fantasy. And so it's kind of much like the work that I'm showing at Photographer's Gallery. It's this exploration of this sort of possibility space or the space of imagination that exists within any kind of computational model. So you always have these, you train a model and you have these kind of example pieces of data that are shaping what this model knows. And then you have this totally vast territory that exists as sort of hidden within this box. And you don't know what that looks like at all. And all you can do is kind of probe it in different ways and try to explore that shape. But it's often really unexpected what is there. And so it is this way of coming to understand what the internal structure is of these kind of alien intelligences that we call AI.
Right, yeah. Which I always find so interesting because it sort of is, I always think of it like a bit like a toddler in the same way that you're like, you have no idea what they're learning or how they've learned it or what they're going to pick up at primary, you know, you drop them off at nursery and they come back with these words and ideas and you have no idea. But I think maybe one project that jumped out to me is a sort of following this through line between predictive and representational and also to a certain extent surveillance is probably Chelsea Manning.
Yeah.
Which is maybe using a similar technique but generating many different versions or potentials. So maybe talk a bit about what you're up to with that.
So what happened with Stranger Visions, so when I started working on Stranger Visions, I was really thinking about this vulnerability of the body. So I was really thinking about trying to make people aware that this that they were shedding this data and that was increasingly easy to read, that it was increasingly easy for someone to come along and mine that data for information. So I was very focused on that. And then I also wanted to show that there is this new emerging technology coming that would called DNA phenotyping, that is this prediction of a face from biodata. And it was very successful and got a lot of attention and I think enacted that well. But what I realized was that it was too reductionist. So it put one face on the data, even though I had behind the scenes generated 6 and totally artistically, subjectively chose one and put that, you know, one face on the wall. So it was very good at achieving the goals that I had, which were thinking about surveillance and thinking about this new technology, but it didn't invite people into the complexity that was really there.
And the agency perhaps as well.
Absolutely.
Yeah.
And this, actually the artistic process.
Yeah.
And with probably Chelsea, I wanted to really bring attention to how multiple these interpretations of data really are and how much creating a portrait from data is this artistic act and is this subjective act, is this kind of storytelling act. And actually how all data interpretation is personal and subjective and involves this layer of curation.
Maybe just very briefly and it might be quite useful now to actually just unpack slightly what you mean by, you know, so you generate a face and then there are different options. So what sort of, based on the DNA that you have, where do you generate, is there sort of like a field of possibility for what a face can look like?
Absolutely. So to give you an example, so working with Chelsea Manning's DNA, so I might look, for example, at a trait like eye color. And analyzing eye color, I might see that someone has a set of genetic variations that indicate they would have let's say, a 60% chance of having blue eyes. So they have a 60% chance of having blue eyes. So if you were to flip a coin, most likely they would end up with blue eyes. But they also have, let's say, a 30% chance of having brown eyes and a 10% chance of having green eyes. And so what I try to do in Probably Chelsea is give space to these other interpretations as well. So instead of just going with the kind of majority probability, to also literally allocate space for the minority possibilities as well. And put out this kind of constellation of probabilities that you can encounter and walk through and think about really how subjective this act of interpreting data is.
And what was obviously this has a political implication, so what was choosing Chelsea Manning as well, for example, I think has quite a political force to it. What did you see the political implications of that being? So
I ended up working with Chelsea Manning while she was in prison. It started in 2015, I think, with the first piece, which was Radical Love. And this was originally 2 portraits of her. And so when Chelsea was imprisoned, this was the time when she announced her gender transition as well. So prior to her sentencing, she was known as Private Bradley Manning. And at the time of her sentencing, she announced her gender transition. But this was also the moment when she could no longer be visited and she could no longer be photographed. No one could interview her in person. No one could take her picture. And so in a sense, her face and her identity became centered at that moment. And so sometime later, Paper Magazine contacted me because they were doing an interview with Chelsea through the mail. And they were interested in having some kind of picture to accompany it, but they couldn't go and take her picture in person. And they together had come up with this idea of doing a DNA portrait because they'd seen articles about my work. And so they said, would you be willing to create a portrait of Chelsea if we could get you her DNA? And I said, absolutely. Not only because I really admired her and would want to, create this portrait in a way to pay tribute to what she did, to her courage, but also because it was at this moment that I was struggling with how do I show the complexity around genomic identity? How do I show that it isn't actually just one read? And then I realized that in working with Chelsea, we could tackle the issue of genetic sex directly. And so what we did first was have 2 portraits to represent her, one that had a kind of androgynous gender and one that was algorithmically parameterized female, and put the 2 side by side as a way of challenging this reduction around sex. And then that expanded to 30. So that was kind of the wonderful and fantastical next thing that happened. I mean, so it's a longer story, but Obama commuted Chelsea's sentence and she was released from prison, and to celebrate her release, we worked together on Probably Chelsea, which showed then 30 of these different possibilities of how you might interpret her data, and really filled this gallery space with this crowd of possible Chelsea Mannings.
In a way, how can we sort of then map that onto so you're in London for an exhibition at the Photographer's Gallery, which is called 1000 Heathers.
So the project at the Photographer's Gallery has, over the course of my research, morphed. So as is often the case, I'll start a project with some kind of question. So in Stranger Visions, the question was, how much can I learn about a stranger from a hair? And in the most recent research, kind of coming back to AI in a way, coming back to facial recognition, I was wondering how the facial recognition system sees me and how I'm represented inside of the model. And trying to kind of break in, and in a sense, you could even think of it as a kind of intimacy with these algorithmic systems, that they're looking at me all the time, but I don't know what they see. We have, even sitting here, we have probably 5 cameras pointing at us right now.
Which is disconcerting because I can't see any cameras. Yeah.
They're always there, and they're always or at least I was potentially looking and analyzing and drawing conclusions, and we have very little understanding of kind of what's behind that act and what that vision actually means. And so in this project, I was trying to kind of dive inside that and see how much I can learn about how I'm seen by the camera, by the algorithmic system.
So how do you go about that?
So so I have this background in kind of AI programming. Been doing that since undergrad. And I have long been interested in neural networks and also genetic algorithms. So genetic algorithms are a way of kind of simulating evolution in code. And so you can put the two things together and you can use a genetic algorithm to generate neural networks. So you can have this kind of evolution of neural networks. And you can use that for solving kind of optimization problems. So like, let's say you don't know what the solution is to some kind of problem, but you know what the goal state is. So in this case, I don't know what the solution is, but I know the goal state is recognized as me by facial recognition. And then you can evolve these images that get that start maybe from random noise or random shapes, and then progressively over time get closer and closer to what's recognized as me until ultimately they meet that goal and are indeed recognized as me. But what they give you...
So you've given them a picture of yourself.
So I trained the facial recognition system to recognize me in the way that we ordinarily would think of it, so that you could give a picture and it would say Heather.
And label.
Exactly.
Picture of me and label.
And then I took that system that was trained
How many pictures did you give the system?
It only needs one.
Really?
Which is really actually very surprising. But the way that these systems work now, which has changed over time, but the way that the systems learn now, the model is trained on millions and millions of actual face images of different people, and then has an ability to generalize from that and to assign a kind of what's called a feature vector, so a set of numbers that numerically represent an identity. And similar pictures or pictures of the same person should, after the system is trained, have feature vectors that are very similar to that one. And so you can give it more than one picture to train on. But what I found actually in testing it was that even with just one, it worked really surprisingly well at finding pictures of me.
So how would you test how it worked?
So I then, so after I saw that I could train it on a picture of me and then give it pictures of me from across the years, pictures of me with long hair, pictures of me making funny faces, etc., and that it would recognize those as me. Then I started testing it with my evolved, strange algorithmic pictures. So I wrote the code that generates these kind of random shapes, and then the random shape gets presented to the facial recognition system, and it outputs a score. And the score will say how close that is to Heather.
And also like 1 to 100, this is a 1, this is so not like Heather.
Exactly.
For example. Yeah.
Exactly. And so when you start with random images and you present them, then they'll start quite far away, but some are further away than others. And so then you take the ones that are scoring the best and you mix them together or breed them and create a new population, a new generation of images. And then you test those. And again, you take the ones that score the best and you cross them over and you add a little bit of randomness or mutation so that there's always a little bit of change happening.
Right, so this sort of, you're using sort of like a language of DNA here, which is, really interesting.
Exactly. And so over hundreds of generations, you end up very often evolving a solution that is recognized, let's say, at the 100% level as being Heather.
Right.
But it has really no resemblance at all to what we would see
I was going to say,
as
yeah,
Heather.
so, I mean, having looked at this video, you see, and you're saying you sort of like, you run through all these images and then you get this point where a green little square appears, and that's a moment when it's like, Heather, this is Heather. And these are, to describe them, sort of like grey swirls of colour, maybe with a dot somewhere. I wouldn't be like, oh, there's Heather.
Absolutely not.
So in what sense is this? I mean, I'm just, how does that happen? How does that look at that image, which for me looks nothing like it, and allocate it that?
So you have
label?
to imagine this space that's multi-dimensional, which we can't really easily imagine. So just imagine, let's say, a 3D space. And you have to imagine that there's this, let's say, face in the middle. That's the face that you might see me as. And that's sort of the attractor. And then swirling all around that attractor are faces that some we would recognize as me, and some are totally unrecognizable. And they are as close to my face in this kind of attractor system as the faces we recognize, because the way that the AI is structured is so vastly different from the way that we understand things. And so there can be things that are right next to each other that to us have seemingly nothing in common, that look totally different, but there is a mathematical connection between them of some kind. It's just not something that we can easily understand.
I really like the way that you described that. That's immediately what it makes me think is that's really scary, because it comes back to this question we briefly touched on, which is the black box problem, and the sense that not only can we not know how these systems are making their inferences, but there's not a clear sense in which we can even be given that information or comprehend that information.
Exactly. We have created systems that are so complex that we have actually no chance of ever understanding them.
There was, I think that the nice example of this, even in a very small sort of ludic context, is the DeepMind AI or algorithms that I forget the specific example that beat a world-class Go player.
Oh, yeah.
In a way that was so, people, masters of the game, note this particular move that they see as just absolutely unquantifiable and non-existent in the history of the game. And that's how this machine won, by completely negating any form. And that's just within a very reductive system. So even within, I guess, a very clear model, like chess, it can still completely upend the rule system. So then I guess when you magnify that out onto the sort of vast data set that is quote-unquote reality, where do we stand?
Exactly. I think that's such a great connection. There's two things that come to mind from that. One is this major political problem that when we use these systems that we don't understand and we put them in positions of power and imagine that they're objective, that can lead to really big mistakes because we don't really understand what we've made, and we don't understand the ways in which it differs from human decision making. So there's a political urgency to that. And then the kind of neighboring thing, which is actually really interesting, is thinking of, well, what if instead of using these things in political contexts and giving them so much power and authority, instead we saw them as these others and used them really in creative ways. And so thinking of gameplay and thinking of art making. The most intriguing thing that could really happen with art and AI would be to have AI that can generate art that is unimaginable to us. And we haven't seen much of that. I mean, mostly when you say AI art, it's sort of like, oh, this AI made a portrait and it's, looks like a 19th century painting or something. It's like, okay, that's a bit boring, really. I want to see AI that makes art that I could never think of myself. Yeah. And so that's, I think, the interesting space. So it's simultaneously what makes the AI exciting and what kind of draws us to it, I think. And on the other hand, it's exactly why it shouldn't be used in positions of authority or in political situations.
more podcasts from Tank, subscribe on iTunes and follow us on SoundCloud.